Hi guys, my name is Samuel Jasper. I'm from CSE department from fourth sem. My topic for database management systems is on next gen power grid. Let's look into what is next gen power grid is all about and how it works. What are the challenges we face in it, and what are the advantages and the disadvantages in it. Introduction: a next generation power grid or a smart grid is an advanced electricity network that uses digital technology, communication systems, and databases to efficiently manage the generation, the distribution, and the consumption of electricity. What it tells is the next generation power grid, which is also known as smart grid, it is an advanced electricity that we gonna use in the future or near future. It it is totally equipped with digital technologies instead of the hardware that we use, like wires and etc. Through this next-gen power grid, it helps us to communicate very fastly and store the values in the database or efficiently manage the power grid. And not only that, we accumulate the power and we distribute it distribute it across the area of the power grid. Unlike traditional power grid, which operate in one-way flow from power plant to consumer, next-gen grid enables two-way communication, allowing real-time interface between the utility provider and the consumer. So, like I said earlier, this generation power grid or smart grid helps us to communicate with two-way instead of only one way, like we do right in traditional way. Only it goes from power plant to consumer. I mean the electricity from power plant to consumer. But next gen power grid is enables us two-way communication, which helps in real-time efficiency and developing the product in much more efficient way. These systems use smart meters, sensors, and IoT devices to continuously collect data about power usage, system performance, and faults. This data is mainly stored in database management systems and also is managed accordingly to the user or inputs and outputs, which helps in monitoring, analysis, and decision making. This is what next-gen power grid is all about. Let's look into challenges, objectives, abstract, etc. Objectives. It improves efficiency, optimizes power generation and distribution to reduce energy waste. In traditional power grid, what it does is um, sometimes they won't. Sometimes the power that is generated is not not received by the consumer, and also the energy is wasted a lot through this method. So what smart smart gen power grid does is it optimizes power generation and helps the consumer to get the electricity in no matter. Real-time monitoring. When the when the power is generated from the power plant to the consumer, the power is monitored how the power is uh, uh, flowing and to what area and to which area and to whom it is flowing. It reduces power loss, like I said earlier. It supports renewable energy such as it integrates with sources like solar, sound, heat, wind, and etc. It enhances reliability, detects and responds to faults quickly to avoid outages. Data is managed in database systems like said it stores. It processes the data and analyzes large amount of data of Power Grid data. Sometimes we can use this data that is stored in the database to train any artificial intelligence models or machine learning models. Methodology and process models. The methodology that we have in this Power Grid is let's look into step by step. First, initially we collect the data and we transmit it, and then we store the data and we again process and we again process the data that is stored in the database system and we analyze this. And when through analysis we make the decision which helps in making system generate and control decision. Let's look into what data it collects and how it collects. Smart meters and sensors are placed in areas. It collects real-time data. It includes power usage, voltage, current, amperes, and volts, falls it has, and etc. Data is sent now. The data collected is transmitted through communication networks, which uses IoT and wireless technologies such as Bluetooth, Wi-Fi, etc. And when the data is transmitted through communication network, it is stored in database. And now the data that is stored in the database management systems is processed thoroughly and it is analyzed extremely and aggressively to know what patterns it has, what faults it has, how we can improve the data, and how we can improve the product, and etc. Through this, we can make a lot more decision making aspect. It helps in load balancing and tolerance handling. Advantages. We have a lot of advantages, but here are the few and the foremost and the top advantages that we have in the next generation power grid or smart grid systems. It is efficient energy distribution. No energy is lost. The energy is always transmitted to the consumer irrespective of the interruptions we face. It is a real-time monitoring and control. It reduces the power that is lost, unlike traditional systems. It is a fast fault detection and recovery. It supports renewable energy such as solar, wind that we have currently going on and is been improving a lot through silicon and etc. Better reliability and stability. It is data-driven decision making using dbms. It improves customer service such as accurate billing, usage tracking. Let's say in traditional systems, the power used to be lost from the power plant to the consumer. The electricity couldn't get reached to the consumer. So what happens is the energy is lost and the usage is lost. They cannot use it. They cannot uh, you track the electricity that they get. But what this smart grid does is uh, we can track the system, and there is 100% guarantee that we get the electricity from the power plant. And also we have an accurate billing, and we can track the power, electricity, and how it is being flowing from the power grid to consumer and the consumer to power plant. Like as I've said, it is a two-way communication system. It is an automated automation reduces human errors. It is scalable system for future expansion. Disadvantages that we have. It is an high initial implementation cost, complex system design, data security and privacy concerns. Like I said, it is a two-way communication unlike traditional system which is a one-way system. To design this two-way communication system, it requires complex system design, and any small error in the design uh, might might result to the fall of the system. So we need to be accurate in designing the system design, and also maintaining it is very difficult and very is also expensive and costly. Dependency on communication networks, risk of cyber attacks. Like as I've said, the electricity can be tracked and is accurate. So with the any with if any hacker or any cyber attack is done on the system, it gives us a lot of data to track us or to track the electricity that we have, and might lead to crime scenes and etc. And when handling data, large data volume is challenging. It requires skilled professionals. Usage, smart home and applications, real-time monitoring, dynamic pricing, which is electricity cost changes based on demand. Users save money by using power in off peak hours. It is a demand response. Mobile and web apps can be used, which can monitor, control, and managed according to results. It improves reliability, cost savings for users, increased use of renewable energy, active user participation. low environmental impact, and etc. Outcomes. The outcomes that we have through this are it is an active user participation. Users become prosumers, both producers and consumers of energy. It is a faster fault detection and restoration. It is a good support for future technologies and better demand side management. Conclusion. The next gen power grid is a modern intelligent system that improves the way electricity is generated, distributed, and consumed. It enhances efficiency, reliability, and sustainability by using digital technology, automation, and real-time communication. It allows users to actively participate in energy management through smart homes, renewable energy integration, and real-time monitoring, and etc. Thank you.